Okay, so we're in chapter 8 now, which is matrices and determinants. The whole idea is solving multiple linear equations or systems of linear equations. So the first exercise is number 7, which it says use the augmented matrix for this system of linear equations. So we have 4x minus 3y is equal to negative 5, and negative x plus 3y is equal to 12. So the augmented matrix means that you include the coefficients of the unknowns, but you also include the numbers on the right-hand side of the equation. So augmented just means that you add a little bit on. So if we just did the 2 by 2 matrix, which represents the coefficients of the unknowns, that would be it would be 2 by 2. What you do is you draw kind of a dashed line to show that this is separated, and then you write minus 5 and minus 12. So that's the augmented version of that system of 2 linear equations. Okay, and the next one says write the system of linear equations that are represented by the augmented matrix. So our augmented matrix is 4, negative 5, negative 1, negative 11, 0, 6, 3, 8, 0, this little vertical dash line, 18, 25, negative 29. So the corresponding, going the opposite direction, we're going to have x, y, and z because we have 3. So we get 4x minus 5y minus 1z equals 18. Then we have negative 11x from there. We don't have any y, plus 0y plus 6z equals 25. And 3x plus 8y plus 0z equals negative 29. And ultimately you don't need the 0 parts, you can just leave those out, but that's just and ultimately what we want to do is we want to figure out what the values of x, y, and z are such that all 3 of these equations are satisfied. Okay, number 19, fill in the blank using elementary row operations to form a row equivalent matrix. So what we do on these is we ultimately want to get 0, 0, 0, 1, 0, 1, 0, 0, 1, and then we can use that to find z and then y and then x. Or if you have 1s on the diagonal and 0s here and 0s there, then the solutions are in that. So you have to do these matrix row operations like multiplying by a constant, subtracting, and adding. Okay, so back to number 19. This is 19. So we have 1, 4, 3, 2, 10, 5. So that's the original matrix. And then the subsequent matrix is 1, 4, 3, so we don't do anything to the first row. And then we have 0 and negative 1. So the question is, how do you get 0? Well, you can't just divide by a constant because you'd still have a number here. So what this involves is probably taking this row, multiplying by a constant, and then subtracting it from this row. So to get this to be 0, starting with 2, we have to subtract 2. So what that would mean is we would take the first row, which is 1, 4, 3, and then we'd multiply it by negative 2. So if you multiply each one of these by negative 2, you get negative 2, negative 8, negative 6. And then you add those to the second row. So let's put the second row in here. So you get 2, 10, and 5. So we add these two rows together. That'll give 0. Negative 2 plus 2 is 0. Negative 8 plus 10 is 2. And negative 6 plus 5 is negative 1. And you can see that that's what I have. I have 0 here, I have negative 1 there, and therefore the answer here is 2. So again, what I've done is I've said, okay, I've got to do something to row 1 so that I get 0 here. And the only thing that I can do is multiply it by 2 and then subtract this row from that row. So what I did was I took the second row, the first row, 1, 4, 3. I multiplied it by negative 2. I got this. And then I added this to my second row. And I ended up with that. And that's how I got the one they're looking for. Okay, the next one, a little more complicated. So we start with this 3 by 4, 3 rows, 4 columns. So you have 1, 1, 4, negative 1, 3, 8, 10, 3, negative 2, 1, 12, 6. Okay, so that's the original matrix. Now what they want you to do is to have zeros here and here. We leave the first row the same. And we ask the question, what do I need to multiply this by? And when added to this gives me a 0 there. So I'm going to have here, write that first row down. We're not changing that, but we're going to use that to do our operations. So if I multiply by negative 3, 1 times negative 3 is negative 3. 1 times negative 3 is negative 3. 4 times negative 3 is negative 12, and negative 1 times negative 3 is 3. Okay, so that's just a multiple of the first row. To get 0 here, I'm going to have to add this row and the modified first row. So I'm going to take my original second row. I'm going to add those, which gives me a 0 here, and that's what I'm looking for. I'm looking for a 0 here, and I'm looking for a 0 there. Now they have 5 and 3. This is going to just result, if I do this correctly, I should end up with 5 here. So negative 3 plus 8 is 5. Negative 12 plus 10 is negative 2. 3 plus 3 is 6. So these are the two things that I enter over here. Negative 2, 6. Okay, then I look at the third row. Well, to get 0 here, I'm going to have to add 2 to this to get 0. So I'm going to take the first row again. 1, 1, 4, negative 1. I'm going to multiply it by positive 2 in this case. So I get 1 times 2 is 2. 1 times 2 is 2. 2 times 4 is 8. 2 times negative 1 is negative 2. Okay. Now I add that to the original third row, which is negative 2, 1, 12, 6. I add those two rows together. I get 0 here, which is what I was looking for. 2 plus 1 is 3. 8 plus 12 is 20. Negative 2 plus 6 is 4. So I've got 0, 3, 20, and 4. So that's the first two parts. Then we do one more step. So the next one, we keep the first row the same again. And we still have a 0 here, but we have a 1 and negative 2/5 and 6/5. Okay, how did we get this? Well, all you do is you take this row and you divide by 5. So this 0 divided by 5 is this, 5 divided by 5 is 1, negative 2 divided by 5 is negative 2/5, and 6 divided by 5 is 6/5. So that's how you get that. And the reason you did that is because the final row is 0, 3. Well, since this is 3, those don't change any at all. So we're just going to put 20 and 4. Now ultimately we want to get a 0 here. So what you would do is you'd multiply this by 3, negative 3, and then add it to this one to get the new row. But they're not doing that yet. So I'm just going to check my answer here in the back of the book. So it's 21, 8.1. Okay, so I get -2, 6, 20, and 4, and I get 1, -2, 5, 6, and so that's correct. Okay, let me put a little piece of paper in here so I don't have to. I guess I could pick my other answers, but I don't think I need to. Pretty confident about those. I took my time. Okay, next one is 33. So 33 says write the matrix in row echelon form. Remember, the row echelon form of matrix is not unique. Okay. So 33. So we have 1, 1, 0, 5, -2, -1, 2, -10, 3, 6, 7, 14. So row echelon form is where you have 1 here, then you have 0 and 1 there, and you have 0 and 0 and 1 there. So first thing I'm going to do is get these both to be 0. So let me just add a page. We'll do the calculations over here. So we're going to start off with the first row again. We're going to multiply that by -2. So we take the first row, multiply by -2. So you get -2, -2, 0, -10. And then we're going to add that to the second row. So that's actually, sorry, multiply by +2. +2. So you get 2, 2, 0, 10. Each multiply to that. Then what you do is you write down the original second row, which is -2, -1, 2, -10. And then you add those two together, and you'll get 0, 1, 2, 0. Okay, so we can write the first and second rows. We get 1, 1, 0, 5. That doesn't ever change. If this is 1, this never changes. Then you have 0, 1, 2, 0. So that's the second row after you've multiplied the first row by 2 and added that to the second row. Okay, the second part is we want to get 0 here. We can only do that. We can't get both of these 0 unless something magical happens. So I have to take 2 steps to do that. So again, you start with the first. Well, actually, we can start with the second row. No, first row. We'll start with the first row. Okay, 1, 1, 0, 5. So we want to make this 0. So this is 1. So if we multiply it by -3 and add them, we'll get 0. So we're going to multiply by -3. Each one of these by -3, so you get -3, -3, 0, -15. Then we copy down the original third row, which is 3, 6, 7, 14. Add those together. -3 plus 3 is 0, which is what we're looking for. -3 plus 6 is 3. 0 plus 7 is 7. -15 plus 14 is -1. So that's what goes here. You get 0, 3, 7, negative 1. Okay, now what we want to do is get 0 here. Now this, and then ultimately we may have to go one more step to get 1 here, but we want to get 0 at this point. So in this case, we're going to take the second row, not the first row. We're going to write that down, 0, 1, 2, 0, 1, and we're going to multiply it by some factor to get to 3, a negative 3, because I want to add negative 3 plus 3 is 0. So we're going to multiply the first row by negative 3. That gives you 0, negative 3, negative 6, 0. So each one of these multiplied by negative 3. Then we write down the third row, 0, 3, 7, negative 1. We add those together. 0 plus 0 is 0. Negative 3 plus 3 is 0. Negative 6 plus 7 is 1. And 0 plus negative 1 is negative 1. So now we can have this matrix. So you get 1, 1, 0, 5. The second row is 0, 1, 2, 0. And the third row is this result, which is 0, 0, 1, negative 1. And this is actually as far as we need to go because we have 1 in the diagonal, we have zeros in this lower quadrant. So they don't ask us to do this, but what does this mean? Well, it means that z, 1 times z is equal to negative 1. So z is negative 1. If we're x, y, z. Those are the unknowns, x, y, z. Now the second equation says y plus 2z equals 0. So what I can do is I can use this previous step information, and I'll get y plus 2 times negative 1, z being negative 1, is equal to 0. Y minus 2 equals 0. Y equals 2. So then I've got the second solution. So the first one is z equals negative 1. Y equals 2. And then finally, my first line represents 1x plus 1y plus 0z, so there's no z's, 0z equals 5. And then I know what z and y are, so x plus y, but y is 2, plus 0, because I've got z, it doesn't matter what z is, that's gonna go to 0, equals 5. So you subtract 2 from both sides, you get x is equal to 3, and there you have the final solution. So those are the values of x, y, and z that would make these original equations work. X plus y equals 5. 2 plus 3 equals 5. And you do the second one, which says negative 2x plus negative y plus 2z equals negative 10. Anyway, let me just look at the answer. So this is 33. So I get, it says there are multiple answers, but I get exactly the same one as the book because that's the most logical way of doing these kinds of problems. And then the final problem, 64. What we want to do, it says use matrices to solve the system of equations. Use Gaussian elimination with back substitution or Gauss-Jordan elimination. Okay, so what we did previously was this Gauss-Jordan or Gaussian elimination. You put it in the form, we did it, and then you solve for z, and then knowing z you can solve for y, and then knowing y and z you can solve for x. The Gauss-Jordan elimination is where your matrix or your final answer is going to be, instead of what we have here, which is my matrix here, which is, one's on the diagonal, zeros here, you get zeros back up here. So you have to go, so I'm going to use that in 64 because that is what seems to be, we haven't covered it. So So you got 64 is 3x minus 2y plus z equals 15. So that's first equation. Negative x plus y plus 2z equals negative 10. And we have x minus y minus 4z equals 14. So the first thing we do is we write this augmented matrix. 3, negative 2, 1, 15. 3, negative 2, 1, 15. Next one is negative 1, 1, 2, negative 10. Negative 1, positive 1, positive 2, negative 10. And the final one is going to be 1, negative 1, negative 4, 14, and 1, negative 1, negative 4, 14. Okay, so the first thing I'm going to do actually is I'm going to move this to the top. So you can switch rows because really they're the same equations. It doesn't matter which one's first. And the reason I'm doing that is because it'll make the subtraction easier. So I switch the first and third rows. Might make it so I don't have to deal with fractions. Otherwise, I'd have to divide this by 3 and then I'd have fractions. So that's okay. Next thing I'm going to do, I'm going to take the first row, first new row. I'm going to multiply by negative 1. So I'll get negative 1 plus 1 plus 4 minus 14. I'll add that to the original second row. Oh, and I should have multiplied by 1, which actually doesn't change it, so I probably don't even need to do that. Let me fix that. So, but I'll include it in because a lot of times you do have to multiply it. In this case, it turns out I'm just multiplying it by 1. Okay, now put the rest of these numbers in here. Negative 10. Okay, now we add the two rows together. So 1 plus negative 1 is 0. Negative 1 plus 1 is 0. 4 minus 4 plus 2 is negative 2. And 14 minus 10 is 4. Okay, so I'm just going to do that for this step. You'll see why in a second. So rewrite the first row, replace the second row with 0, 0, negative 2, 4, and then I'll leave the third row for the same right now. Well, actually, what we're going to do is we are going to go ahead and do that now. So again, we'll start with the first row. And what we want to do is be able to eliminate this to go to 0. So to multiply this by negative 3. So multiply the first row by negative 3. So each of those numbers by negative 3. Then we write the third row in, which is 3, negative 2, 1, 15. So you get 0, 1, 13, negative 42, and 15. That's 30, negative 30, negative 27. Okay, so we can put that in there. 0, 1, 13, negative 27. Now, all I'm going to do is switch the two rows, the second and third rows. Because this one has a 0 here, which that's, so you get third row becomes the second row. Second row becomes the third row. Okay. Next, what I'm going to do is I'm going to divide the third row by negative 2. I'll just leave the second row the same. So I'll get negative, this divided by negative 2 is 1, this divided by negative 2 is negative 2. Okay, so we know that z is equal to negative 2. Now I'm going to use this Gauss-Jordan elimination. What I'm going to do is I'm going to get a 0 here. So I'm going to take this row, the last row, 0, 0, 1, negative 2. And what I want to do is I want to eliminate this. So I need to multiply that by this by negative 13. So I'll take the third row multiplied by negative 13. So I'll get negative 13 and plus 26. And then I add that to the original second row. So I get 0, 1, 13, negative 27. Add those together. You'll get 0, 1, 0, negative 1. So let's do that. So you get negative 4, do that. So this becomes 0, 1, 0, negative 1. The last row remains the same. So now I know y is equal to negative 1. And to eliminate this term, I'm going to use the last equation, or last row. So again, I'm going to start with 0, 0, 1, negative 2, and I need positive 4 to make that go to 0, so I'm going to multiply by positive 4. So that's 0, 0, 4, negative 8. So that's just the third row multiplied by 4. And then I'm going to put in the original first row, which is 1, negative 4, 14. I add those two together. I get 1, negative 1, 0, positive 6. What we're doing here is we are trying to get this to be 1, 0, 0 and something. So we've gotten that 0 out of the way. So let's go ahead and write that in. So you get 1, negative 1, 0, 6, and then this third and the fourth, second and third stay the same. And then finally, now that you've got a 0 here and a 1 there, we can just add these two rows together. We don't really need to. So we're going to take the second row, and we don't have to multiply it by any constant because it's already 1, and we don't have to change the sign, so we're just going to add that to the first row. So that's going to be, so this is the first row, and then we add both together. So here we'll get 1, negative 1 plus 1 is 0, 0 plus 0 is 0, 6 plus negative 1 is 5. So that now becomes our new first row. And now we've got it into the format that we're looking for. So the first row is 1, 0, 0, 5. The second row is 0, 1, 0, negative 1. The third row is 0, 0, 1, negative 2. And so what we can say is that, let's say it's x, y, z. We've got x equals 5, y equals negative 1, z equals negative 2. So that's my solution. And you can check that out, see if it actually works by taking the original equation and then just plugging it in and see whether it works or not. So let's just do that just so you can. So what I'm going to do is I'll move that over here. I'm going to come all the way down to the bottom again. So 3 times x, which is 5, minus 2 times y, which is negative 1, plus z, which is negative 2, equals, okay, so we got 15 plus 2 minus 2, which equals 15, which check. So we got that first one works. The second one, the second equation, we have negative x is 5 plus y plus negative 1 plus 2 times negative 2 equals something. So we get negative 5 minus 1 minus 4. That's going to be negative 10, which is, that one's correct. And then the final one is going to be this equation. So we have x, which is 5, minus y, minus negative 1, minus 4 times negative 2. So that's 5 plus 1 plus 8, which is 14, which is the last one. So that is the correct solution to the whole thing.